Okay, so we are up to chapter 4, section 5, which is going to talk about congruence in right triangles. And if you recall, before Thanksgiving break, we have repeatedly talked about there are 4 ways to show triangles are congruent. And those 4 ways that we've talked about, the first one was side, side, side. If we could show that 3 sides of one triangle were congruent to 3 sides of another triangle, then the 2 triangles were congruent to each other. Therefore, all their angles were going to be congruent as well. We also had side, angle, side. We had angle, side, angle. And we had angle, angle, side. So far, those were the 4 different shortcuts that we had for showing that triangles were congruent. Well, there is actually a 5th one. We're going to show that to you today. And it is congruence in right triangles. And this particular shortcut only works in a right triangle. So we got to recall, what's a right triangle? Well, a right triangle is a triangle that contains a right angle. So if we have a right angle in the triangle, it's a right triangle. It says, suppose we have a pair of right triangles and they don't satisfy our triangle criteria. Let's say it doesn't satisfy one of these. So if you look at this, we have a congruent side that's 4 inches and we have a congruent side that's 5 inches. So we have 2 sides and we have 1 angle. The right angles, of course, would be congruent to each other. So we have 2 sides and 1 angle. Well, the only criteria that we have so far that is 2 sides and 1 angle is that side, angle, side. And the angle that is congruent in the 2 triangles is not in between the sides. It would have to be angle A in this picture being congruent to angle D, and we don't have that. So we don't have any one of these 4. So by side, 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 we talked about how side, side, side is not an option. We cannot use that. Okay, so but instead of looking at these 2 triangles and say, well, they're not congruent, we actually have something else to work with a right triangle. If you recall, we have what's called the Pythagorean theorem. And if I were to use the sides here and say a squared plus b squared equals c squared, c being the hypotenuse, which in this case is the 5 inches, if I plug that into my formula, I'm going to come out with a third side of being 3 inches. And it would have to be the same on both triangles, because for both triangles we would use a squared plus b squared equals c squared. And both triangles we would substitute 4 in for the a or the b, it wouldn't matter, but c would have to be the 5 inches, and in either case we would get 3 for that third side. So because the missing side in both triangles is 3, we would now have congruence by side, side, side. That would then be our reasoning for saying that those 2 triangles are congruent. And this only works on a right triangle. Okay, so what we call that, slide this up here. So using that information, when a right triangle is involved, we call it the hypotenuse leg congruence theorem. So now we're going to have side, side, side to choose from. We're going to have side, angle, side. We're going to have angle, side, angle. We're going to have angle, angle, side. And now the 5th one is called HL, and that stands for hypotenuse leg. If you have the hypotenuse of a right triangle and you have one of its legs as being congruent, then you have enough to say that the 2 triangles are congruent. So as we call it the hypotenuse leg congruence theorem, if the hypotenuse and one leg, doesn't matter which leg, but hypotenuse, it has to be the hypotenuse. The hypotenuse is the longest side of the triangle, and it is the side that is across from the 90-degree angle. So here's a 90-degree angle. The hypotenuse would be segment UT. Okay, over here, if this is 90 degrees, this would have to be 90 degrees. So the segment that's the hypotenuse over here would be UV. It's across from the 90-degree angle. But anytime I have the hypotenuse and one leg of a right triangle is congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. Okay, so let's see what that proof looks like. It says write a 2-column proof. It says given to me, and again, we always start with the given information when we're writing a proof, so I'm going to copy that down and say segment UT is congruent to segment UV. And that's given information. And after I write it in my proof, I want to go mark it on my picture. So segment UT is congruent to segment UV. And I want to prove that angle T is congruent to angle V, so that's going to be my bottom line. I want angle T congruent to angle V. And again, I keep saying this, If that's all you know how to do in the proof, at least write that down. Start with the given, that's on the first line, and what you're trying to prove should be on the last line. Now these are parts of the triangle. Before I can prove that the parts of the triangle are congruent, I have to prove that the triangles are congruent. So that's what I'm working for, is to prove that these two triangles, these small triangles that you see, are congruent to each other. Okay, so the reason for the step 2 is given to me, reflexive. Which side in this triangle on the left is the same as this side in the triangle on the right? Which side do they share? Okay, if you said that segment US is congruent to segment SU, you are correct. They're sharing that side of the triangle. It has to be congruent to itself, and we still are calling that the reflexive property. That's enough information to say that the triangles are congruent. So triangle TUS is congruent to triangle VUS. And now my reason is going to be HL. It's a right triangle. You see the right angle. And the hypotenuse is the side that was given to me. That's the hypotenuse of both triangles. And the reflexive side was the leg. So since they have a hypotenuse and the leg of both triangles are congruent, we can say that the triangles are congruent. And if the triangles are congruent, then we can say that angle T is congruent to angle V by CPCTC. Remember, that stands for corresponding parts of congruent triangles are congruent. So this is what my proof would look like using the hypotenuse leg. So you're going to continue to work on this. You have a worksheet that you're going to work on. And like I said, it just adds one more criteria, one more shortcut to our list that we've already been using. Go ahead and work on that worksheet.